Ever wonder how to swap multiple characters at once in Python? Stop relying on repetitive, messy replace functions. There's a far more efficient way to handle bulk swaps using the makeTrans method. It's built right into Python's string class, making your code incredibly fast and clean. You can see it right here, it's part of the standard str class. Let's break down how it actually works. Suppose we have a string called apple pie, stored inside this text variable. Our goal is to instantly swap out every A and every E across the entire string. Think of this like a high-speed password generator. You know how people swap letters for numbers to make passwords more secure? That's exactly what we're doing. We'll map A to that symbol and E to the number 3. The method takes two main arguments to create this map. Essentially, it's generating a high-speed translation table. If you hover over the method, you'll see makeTrans in action. It returns a lookup guide that Python uses for lightning-fast swaps. Simple, right? Now, we take our text variable and call the translate method. This method takes that mapping table we just built and applies it. We plug the table in right here. Translate accepts the table and processes the entire string in one go. When we run it, look at that. Apple pie is transformed. Every A is now an at symbol and every E has become a 3. But there's more. You can actually delete characters using a third argument. Check this out. We leave the first two arguments empty and use the third to list what we want to vanish. Let's hit run and see the magic happen. Look at the output. It wiped out the numbers, including the 0 in room 204. It removed the 4 as well, leaving us with just room 2 and the exclamation mark. If we want to ditch the exclamation mark, we just add it to that third argument. Just like that, the punctuation is gone. Now, what if we want to change room to boom? We simply tell the map to replace the letter R with a B. Since B is now in our mapping, it instantly becomes boom 2 instead of room 2. Keep in mind, case sensitivity matters. A lowercase r won't be caught if you only specified an uppercase r. Let's add the number 2 to the deletion list, and now the 2 is wiped out completely. We can even throw a space character in there. And there you go, all the spaces have vanished. This is vastly more powerful than chaining a dozen replace calls together. The same logic applies if we want to delete all the P characters. Just add P to that third argument and they disappear instantly. This is a total game changer for string manipulation in Python. Just remember, use makeTrans to build your logic table, then use translate on your variable to apply it. Store the result in a new variable, and you are ready to go. Are you planning to use these string methods for data cleaning or something like a custom text encoder? Master Python's Zfill method in seconds. The ultimate way to zero-pad your numbers. Say we have an order ID of 42. We need this to be exactly 5 characters long. By calling Zfill and passing 5 as our parameter, we get this clean result. Check that out, a perfect 5-character string. The original 42 was only 2 digits. So Python automatically prepended 3 zeros to the front. It gets even better when handling negative numbers. In this case, we set our target length to 4. Our starting value has 2 digits. Python adds 2 zeros, but here's the clever part. It pads the divs, but keeps that negative sign right at the start. It's smart enough to preserve the mathematical sign. This is perfect for professional invoice systems. Instead of a messy invoice one, you get a sleek, padded format. Watch how much better this looks. Let's add our number here. We want total consistency. No more jagged lists of digits. If you need those leading zeros, this is the cleanest way to do it. Here is how you implement it in your code. We take the string inv and concatenate it with our invoice number variable, applying Zfill directly. If the number is 37, notice we're calling it on the variable itself. We are filling the value of this specific variable. Setting the width to 6 characters gives us this beautiful, formatted ID. This works wonders for file names too. Trying to sort files manually can be a nightmare. Computers often put file 10 before file 2. But with Zfill, you can standardize your naming convention. Adding zeros ensures your files sort in the perfect chronological order. No more messy folders. Just take the file number and set a 3-character width. Need 4 characters? It's just as easy. Change the argument to 4 and you're instantly updated. This is a total game changer for organizing data or exports. It's also incredibly practical for dates. If your month is 3 or 7, you'll want that professional 03 look. Just run Zfill with a width of 2. Now you have a consistent 3 and a 7. And here's a pro tip. If your number is already longer than the width you set, Python won't touch it. It stays exactly as it is. You have total peace of mind. It won't mess with your large numbers or truncate them. You can even use this to generate IDs on the fly, running a loop from 1 to 6. If you want those IDs to be 4 digits long, simply apply Zfill inside the loop. Don't overcomplicate your range logic. Just Zfill and you're done. Ever wondered how the split method actually works? And more importantly, how you use it in the real world? Let's break it down right now. First, keep in mind that by default, Python uses a single space to slice your text. Check out this string I've set up. You'll notice there are multiple messy spaces in there. What do you think happens next? Will it keep those gaps? Let's hit run. Look at that, it completely cleaned them up. The extra white space is gone, leaving just the core values. It's an incredibly efficient way to handle dirty data. This is a massive time saver when you have inconsistent spacing but need to extract specific words. Now, let's look at a different scenario. As a developer, you'll constantly deal with comma-separated data. To parse that, simply tell the method to use a comma as the separator. Remember, no arguments means it looks for spaces, but pass in a comma, and it transforms the string into a clean list like this. Now we have John, developer, and London as separate items. That's a name, a job, and a city. For the DevOps pros out there, this is vital for log analysis. You're constantly hunting for errors and system issues. By splitting these logs, you can isolate specific parts of an error message instantly. The first part identifies the status like error or info, then the date, and finally the specific database failure. This is exactly how you build automated monitoring tools that actually work. Here's another example. We're splitting by commas again. Imagine a user has typed multiple tags into a single input field. By splitting them, you get a clean list of tags that you can loop through. But here is a pro tip. The split method has a hidden power called max split. This second parameter limits how many times the string is divided. It tells Python, only split this many times and stop. It looks something like this in practice. There is our first split, and there's the rest. It creates the number of splits you ask for, plus one final remainder. So if you enter 2, you'll end up with 3 parts total. If you enter 0, it won't split at all. But if you enter 1, it chops the string into 2 distinct pieces. This is perfect if you only need the first label and want to keep the rest of the message exactly as it is. Just notice that when using a custom separator, it keeps trailing spaces. See that space right there? It stayed in the result. If you want that gone, you have to be specific. Watch this. By including the space in your separator, you can strip it out right at the start of your logic. It's all about control, clean data, clean. Let's dive into the fundamentals of Python Booleans. Now, don't let the simplicity fool you. Stick with me, because I'm betting there's a nuance here that will definitely surprise you. Let's break it down from the top. Booleans are defined by 2 specific keywords, true and false. But here's the catch: Python is strictly case sensitive. You can't use lowercase t for true. The first letter must be capitalized. If you try to write it in all lowercase, the code will fail immediately. Always ensure you use a capital T and capital F. When we execute this, you'll see the console recognizes them perfectly as Boolean values. Those are the specific keywords Python is looking for on your screen. Let's look at a practical scenario. Imagine checking a user's age to see if they can access a dashboard. We test if the user's age is greater than or equal to 18. If that condition is met, it returns true. Running this gives us a true result, meaning the user is clear for dashboard access. Simple, right? Now let's ramp up the complexity. We have 2 variables. Is the user an admin, and is 2-factor authentication enabled? We'll hardcode these as true and false for now. First, we use the AND operator to check if both conditions are met. If they are both an admin and have 2-factor on, they can modify settings. However, for viewing a basic report, we might only need one of those to be valid. By using the OR operator, the logic changes. OR only requires one side to be true to return a positive result. So while the AND check might return false, the OR check will still successfully store true value in our variable. And there it is. Modifying settings is false, but report access is true. It's all about how you stack those operators. Here's an even more interesting use case: an unpaid invoice. How do we determine if a customer is eligible for a discount? Today might be their lucky day. If they have paid the invoice and the total amount is over 100, we grant them that discount. In this case, the condition evaluates to true. The expression is valid because both parts of our AND logic were satisfied. Notice the AND keyword right here in the middle. That is the glue making this logic work. Both sides must be true for the whole thing to pass. Now, let's look at something really powerful. We have a list of tasks here: emailing a client, generating reports, and backing up data. Next to it, we have a list of completion statuses. The first is true, the second is false, and the final one is true. We're going to pair these up using the zip function so we can iterate through them simultaneously. This creates a collection of pairs. Notice both lists have the exact same length. As we loop through using zip, you'll see the results. The client email, completed. The report generation is still marked as pending because that value is false, and the data backup is finished. The zip function is a fantastic way to combine your data with Boolean flags. Inside the loop, we just check. If the status is true, mark it completed. Otherwise, it stays as pending. One last pro tip: any populated list automatically evaluates to true. By passing a list into the Boolean class, it returns true if there's data inside. But if that list is empty, it returns false. Converting objects like this is a quick way to check for empty data structures. If it's empty, it's false. If it has content, it's true. This is an incredibly useful trick that you will use constantly in your real-world projects. Think you've mastered Python's arithmetic operators? I'm betting there's more to learn. Let's take a fresh look at these tools from a professional perspective. We'll start with the fundamentals. Look at these invoices: January, February, and March. To calculate the total, you'd likely add them up. Simple, right? The plus operator is the standard way to handle addition. But here's a pro tip: you can actually store these in a list. By organizing your invoices into a list, you can use the sum function. This is a much cleaner approach. Using the sum function on a list, defined by these square brackets, makes your code more efficient and readable. Just pass the list to the sum function to calculate your total instantly. Instead of chaining plus signs, let the sum function do the heavy lifting. As you can see when we run this, the results are identical to manual addition. Now let's look at managing a budget. We had a total budget and our actual spending. We need to subtract the amount spent from our total budget. The remaining balance comes out to exactly $1724.5. In a real-world scenario, your expenses might be pulled from a database. You can group them in a list, total them with sum, and then use the subtraction operator to find your remaining budget. Lists are incredibly practical for these kinds of workflows. I hope you're finding this useful so far. Let's keep going. Here is another common calculation. We have a unit price and a quantity. Multiply them together, and we get the total order cost. Now, this is where Python gets interesting. The multiplication operator isn't just for numbers. It works on text too. Suppose you want to repeat a string 3 times. By multiplying the text, look what happens. We get alert, alert, alert. It's a fast, easy way to generate repeated patterns or warnings using simple math. It works seamlessly for both math and strings. Finally, imagine you have 37 tasks and 6 team members. How do you distribute the workload evenly? It's easy. Just use the //. This is known as the floor division operator. Then we have the modulus operator, which identifies the remainder. Let's see this in action. For tasks per member, the floor division, tasks divided by members, tells us to assign 6 tasks to each person. But what's left over? By checking the remainder, we can see exactly how many tasks remain. In this case, 1 task remains. Since 6 times 6 is 36, that final task hasn't been allocated yet. As a manager, you might step in and handle that 1 extra task yourself while the rest of the team handles their 6. There you go. The team is busy with 6 tasks each, and you take on the remaining 1. Remember, floor division is your friend for even splitting, and the modulus operator tracks what's left behind. I told you there was more to these operators than meets the eye. I hope you enjoyed the lesson. Let's dive into the power of Python operators, specifically arithmetic operators, and see how they solve real-world problems in your code. Forget the boring theory. We're going straight into practical, pro-level examples. Take a look at this list of employees: John, Bob, and Charlie. Our goal is to automate a shift schedule so the manager knows exactly who is on duty on any given day. We have our employee list ready to go right here. All we need to do is provide a day number, and Python will calculate who is assigned to that shift. We'll start by accessing our employees. By targeting the list index, we can pinpoint the right person. The secret weapon here is the modulus operator. We're going to calculate the total length of our employee list. Since we have 3 team members, we'll take the day number and find the remainder when divided by 3. Watch what happens. If I run this for day 6, the system identifies that John is on duty. But what about day 15 of the month? It cycles back to John. On the 16th, it's Bob. On the 17th, Charlie. So who's up for the 18th? You guessed it, we're back to John. This illustrates how the modulo operator creates a perfect, repeating loop. Starting at index 0, we get John. Day 1 is Bob. And day 2 is Charlie. Always remember, Python uses zero-based indexing. So, day 0 is today. Day 1 is tomorrow, and the day after that is day 2. That brings us right back to Charlie at the end of the rotation. This is a brilliant, practical way to handle shift patterns and rosters. No more manual tracking, just calculate it dynamically. And the code scales automatically, even as you add more people to your team. Ever wonder how to calculate future value? Let's master it using Python's powerful arithmetic operators. Specifically, we're using the exponentiation operator, the double asterisk. Imagine an item worth £1,000. Our goal is to track its growth, as it appreciates by a rate of 0.05 every single year. In just 3 years, what will that future value be? Essentially, we are looking at a 5% annual increase. Run the code, and there it is. That £1,000 item is now worth £1,157.62. But how does Python actually solve this? It all comes down to the built-in order of operations. Python prioritizes parentheses first, followed immediately by exponentiation. Those two multiplication signs you see right here, and then it handles multiplication. It continues through division, floor division, and the modulus operator, before finally finishing with addition and subtraction. In our formula, Python first calculates the growth rate. That's 1 plus the rate inside the brackets. Next, it applies the power. Think of it like basic math. If you raise 2 to the power of 2, you get 4. Our formula works the exact same way. Now, notice how we can add brackets around the expression. By using parentheses, you are making it explicitly clear that you want the exponentiation handled first. Even though Python does this by default, adding them ensures the math is fully calculated before the final multiplication takes place. The principal is multiplied only after the growth calculation is complete. Let's run it again with those parentheses, just to show you how much cleaner the logic looks. To be honest, I always prefer using parentheses. They provide total clarity and prevent any confusion for other developers who might be reading your code later on. Use parentheses, and you get that same perfect output of £1,157. Now, imagine if it grew by 100% every year. In 3 years, that original investment would skyrocket. That is the true power of Python math. Let's compare the traditional way of assigning values to the lightning-fast modern method using operator shortcuts. These shortcuts are absolute game changers. You might have seen them before, but truly mastering how they work is the difference between a beginner and a pro. Take this variable x. If we want to increase its value by 5, this is how you would typically write it. You set x equal to x plus 5. Simple enough, right? But this old-school approach manually overwrites the original value. In terms of raw speed, that long-form version has no real benefit over the streamlined plus equals syntax. For basic numbers, both methods perform exactly the same. That is because integers in Python are immutable, they cannot be changed in place. However, when you apply this same shortcut to something like a list, the performance is massive. Look at this numbers list. Here, we are trying to add 2 more items. The old way forces Python to copy the entire list, add the new data, and then save it all over again. That process is a total memory hog. But watch what happens when we use the shortcut method instead. By using plus equals to add our new items, 4 and 5, we unlock a much smarter workflow. This simply appends the items directly to your existing list, saving you from wasting memory and processing power. Ditch the old habits and start using the plus equals operator today. Technically, it won't change your speed for unchangeable types like strings or basic integers. But for lists which are flexible and mutable, this choice is vital. You will save massive amounts of memory and keep your code running lean. It is objectively more efficient than the alternative. Make this your default method whenever possible. Plus, from a readability standpoint, this just looks cleaner. It is faster to type and easier to read. You avoid repeating yourself and eliminate the risk of typos in your variable names. If you try to retype X, you might accidentally hit Z instead, And trust me, you don't want to deal with those bugs. The Walrus operator is a powerful new addition to Python. If you haven't used it yet, you'll want to pay close attention. First, let's look at the traditional way of doing things. To check the length of a variable like this one containing hello world, we would typically store that length in a dedicated variable first, and then verify if that value is greater than 5. If the condition is met, we print the result. It's straightforward, but is it efficient? In this case, we get a length of 10. That is clearly greater than 5. So what is the downside to this approach? The issue is redundancy. You are forced to write an extra line of code just to capture the length of your text. Then you must write a separate line for the if condition. Now, you could try to skip the extra variable. You might calculate the length in the condition, and then calculate it again just to print it. While that avoids a variable, it creates a new problem. Even though the len function is small, it still requires processing power every time it runs. Doing this repeatedly consumes unnecessary CPU resources. It makes your code more expensive to execute. Enter the Walrus operator. You keep your if condition, but now we use the := symbol to name the value. By using := you are assigning the length to a variable and evaluating it at the exact same time. You only call the function once, checking if the value is greater than 5 right where it's defined. Then you can simply print that length. The assignment and the if condition happen on a single line. It evaluates as it assigns. This approach is incredibly useful for real-world tasks. Imagine you are processing a large text file. You want to find any line with more than 10 characters. In the old style, checking and printing those lines requires a multi-step process that can be hard to track. As you can see, the result is correct, but the code feels cluttered. It looks unnecessarily complicated. The cleaner way is to handle the logic in one go. We check the length and assign it within the same line. Notice the Walrus operator here. Now we can print the line and its length. This is much more elegant. The previous version used multiple statements spread across several lines, which leads to confusion. Comparing these methods, the double function call is the worst due to performance loss. The standard way is fine, but it's verbose. By using the Walrus operator, your code becomes concise and easier to read. You capture the data, name it, and test it, all in one smooth motion.